Here we will discuss how to protect data in transit and at rest in this upcoming session. We'll take a look at some of the data encryption options available on our platforms. We will also see how to configure data at rest for encryption for Microsoft SQL Server. We'll take a look at how to configure the Azure Key Vault and database and instance firewalls. Lastly, we'll take a look at dynamic data encryption. Encryption at rest is a vital security practice that ensures data stored on physical media remains unreadable without the appropriate keys or certificates, protecting it from unauthorized access. Here we see some key concepts regarding encryption at rest, focusing on what it can protect. It can encrypt data files, transaction logs, and backups, but it will require a certificate to access them and keep them secure when they're not in use. SQL Server and Azure SQL Database use transparent data encryption, or TDE, to automatically encrypt and decrypt data. Azure provides built-in encryption for data at rest through services like Azure Disk Encryption for virtual machines, adding another layer of defense, which uses Windows BitLocker or Linux DMCrypt, depending on your operating system, and Azure Storage and Azure SQL Database, which use storage service encryption and transparent data encryption, respectively. Encrypting data at rest ensures stored information remains secure and unreadable without proper keys, protecting against unauthorized access or data theft from physical media. While encrypting data in transit is going to safeguard information as it moves across networks, preventing interception during transmission. These practices are essential for securing sensitive data in cloud environments, databases, and communication channels, especially in industries like healthcare, finance, and government, where data privacy and compliance are critical. Here we highlight two critical aspects of data encryption: data at rest, which refers to information stored on a physical media, such as a database or a cloud storage, which is encrypted to prevent unauthorized access while the data is not actively moving. This will ensure it remains unreadable without the correct decryption keys. This is visually represented on the left. On the right, we see data in transit, which involves encrypting data as it moves across private or public networks, protecting it from interception during transmission. The slide illustrates this with a database icon connected to both a locked private cloud and an open public cloud, each receiving encrypted data through directional arrows. Let's talk about transparent data encryption architecture, which provides a comprehensive overview of how TDE secures SQL Server and Azure SQL Database by encrypting data at the page level as it's written to the disk and decrypt it once it's read into memory. The left side features a SQL script that walks through the setup, creating a master key in the master database, generating a certificate, creating a database encryption key using AES 256 encryption, and enabling encryption with a simple altered database command. This highlights how easy it is to kind of set this up, roll out TDE. The right side presents a layered architecture diagram showing how encryption keys are protected from the Windows level via DP API down to the user database level, where the database encryption key is a symmetric key and it's used to encrypt data and backups. TDE is enabled by default in Azure SQL, and its benefits include protecting data at rest from unauthorized access, ensuring compliance with regulations like HIPAA and GDPR, and then securing backups from being restored on untrusted servers. Use cases include enterprise database storing sensitive customer or financial data, cloud-hosted apps requiring built-in encryption, and organizations needing to meet strict data protection standards with minimal performance impact. Managing transparent data encryption, or TDE, effectively is critical to maintaining both the security and accessibility of your SQL Server databases. First and foremost, always back up the certificate created in the master database. This certificate is the key to decrypting your data, and losing it could mean permanent data loss. Without this certificate, you cannot restore the database on the same or even another server, making it essential for disaster recovery and migration scenarios. Additionally, if the certificate is missing, it won't be able to read from backups or attach data or log files, which could severely impact business continuity. For environments using availability groups, the certificate must be restored to every participating server to ensure seamless access to encrypted data across the cluster. These practices not only safeguard sensitive information, but also support high availability, compliance with data protection regulations, and secure multi-server deployments, making TDE a powerful tool for enterprises handling financial, healthcare, or personally identifiable information. This slide, titled Configure Server and Database Firewall Rules, presents a strategic and practical approach to securing Azure SQL databases through layered firewall configurations. Each database is assigned a public IP address hosted by Microsoft, and firewalls serve as that first line of defense, blocking all access by default and allowing only trusted connections through. This best practice minimizes exposure to threats and strengthens your overall security posture. Azure offers firewall controls at both server and database tiers, enabling granular access management tailored to specific operational needs. You can configure these rules using T-SQL, for example, to allow access from a specific IP range at the server level. And to do that, you want to use the stored procedure SP-set firewall rule to allow access. Then to allow access at the database level, you want to use SP-set database firewall rule. Server-level firewall rules apply to all databases within that logical Azure SQL Server and are ideal for managing broad access across multiple databases from specific IP ranges. In contrast, database-level firewall rules provide more granular control by restricting access to individual databases, making them especially useful for multi-tenant applications or scenarios requiring precise access segmentation. Server-level firewall rules can be configured using the Azure portal or using the SP-set firewall rule stored procedure from within the master database. Database-level firewall rules are configured through T-SQL only using the SP-set database firewall rule stored procedure from within the user database. When a computer tries to connect to your server from the internet, the firewall first checks the originating IP address of the request against the database-level IP firewall rules for the database that the connection is making the request for. If the address is within a range that's specified in that database-level IP firewall rule, the connection is granted to the database that contains that rule. If the address isn't within the range of the database-level IP firewall rule, the firewall checks the server-level IP firewall rules. And if the address is within the range of that server-level IP firewall rule, the connection is granted. Server-level IP firewall rules apply to all databases managed by that server. If the address isn't within the range that we've had specified for either the database or the server-level IP firewall rule, the connection request will fail. Now let's discuss how network peering enables secure and efficient connectivity from within a virtual network to Azure PaaS services like Azure SQL Database. A key takeaway is that network endpoint peering is region-specific, meaning both the virtual network and the PaaS resource must reside in the same Azure region. This ensures low latency and optimal performance, but requires thoughtful resource placement. Additionally, peering supports only server-level connections, not database-level access, which simplifies connectivity for environments, managing multiple databases, but limits granularity and access control. Another critical point is the need for outbound access to Azure SQL Database public IPs, which must be configured in your network security settings to allow communication with the database. These features offer significant benefits, including enhanced security through private network paths, compliance with regional data residency requirements, and then streamlined server-level management. Use cases for this include enterprise applications requiring secure internal connections and communication, multi-regional deployments needing localized performance, and centralized database administration across distributed systems, all without exposing sensitive data to public internet routes. Private Link introduces a powerful feature for securing connectivity to Azure SQL Database and other PaaS services by using private endpoints. With Private Link, your connection to Azure SQL Database travels entirely over the Azure Backbone network, avoiding exposure to the public internet. This is significantly going to reduce the risk of data interception and enhances overall security. A private endpoint assigns a private IP address within your virtual network, allowing seamless integration with your internal infrastructure. Additionally, Private Link supports Azure Express Route, enabling high throughput, low latency connections, all of this through dedicated circuits for enterprise-grade performance. One of its standout benefits is cross-region private connectivity, which allows secure access to resources across Azure regions while maintaining compliance and data residency requirements. It also helps prevent data leakage by restricting access to specific resources only, making it ideal for financial institutions, healthcare providers, and multi-tenant SaaS platforms that require strict data isolation and secure internal communication. Object-level encryption introduces a powerful layer of data protection in SQL Server that goes beyond TDE, transparent data encryption. While TDE secures data files and backups, it does not encrypt the actual data within the tables. This is a critical gap that's addressed by Always Encrypted. This feature ensures that sensitive column data, such as social security numbers, credit card details, is encrypted in such a way that only applications with the correct column encryption key can decrypt it. This means even database administrators or attackers with access to the database cannot view this protected data. This significantly reduces the risks of insider threats or data exfiltration. The benefits are substantial: enhanced privacy, stronger compliance with regulations like HIPAA and GDPR, and robust protection for high-risk data. Use cases, of course, include financial institutions securing customer financial details, healthcare providers protecting patient records, and any enterprise handling personal identifiable information across distributed systems. By implementing object-level encryption, organizations can ensure that their most sensitive data remains secure even in the event of a breach. This slide highlights the powerful security advantages of using Always Encrypted in SQL Server and Azure SQL Database, offering a layered approach to protecting sensitive data. At its core, Always Encrypted ensures that your data is encrypted both at rest and in transit, meaning it remains protected while it's stored on the disk and while it's traveling between the SQL Server and the client app. One of its most compelling features is the database engine never sees plain text data, which significantly will reduce the risk of exposure from insider threats or compromised systems. Encryption is handled using certificates created by the database that's stored securely in the application, ensuring only authorized applications can decrypt the data. This separation of duties means that even database administrators cannot access this encrypted value. And this adds a critical layer of protection for highly sensitive information like social security numbers, financial records, health data. And it uses a master encryption key and column encryption key to do it, allowing each column to be encrypted independently for maximum security. These keys can be stored in trusted key stores, such as the Azure Key Vault. This gives our organization the flexibility and control over encryption strategy. Benefits here include robust data privacy, protection against unauthorized access, even from privileged users. Use cases span a lot of industries, as we mentioned before, finance, where we want to hide some of the customer account details, also in healthcare to secure our patient records that need to be strictly confidential, and government can use this too, where they have classified data must remain inaccessible to unauthorized personnel. Always Encrypted will help with this, and it allows organizations to confidently safeguard their most sensitive data while maintaining performance and operational efficiency. Always Encrypted encryption types show a clear breakdown of how SQL Server and Azure SQL Database can protect sensitive data across different deployment scenarios using two powerful encryption methods. Here are three key scenarios. One, you can use it when both the client and the data are on premises. Organizations can use this to safeguard against highly privileged users like external vendors by keeping full control over the encryption keys. You can also use it in a scenario when the client is on premises, but the data is in Azure, and then storing always encrypted keys locally or even in your Azure VM will ensure that even Microsoft Cloud administrators can't access your decrypted data. And another scenario is where you have both client and data located in Azure, and we have encryption within the database itself where we maintain strong protection in the cloud and in native environments. There are also two encryption types to be aware of. Deterministic encryption, which consistently produces the same ciphertext for giving plain text and supports operations like equality joins, indexing, and grouping. This is ideal for fields like customer IDs or email addresses in financial or retail systems. And randomized encryption, which generates different ciphertexts for the same plain text each time, offering maximum security for highly sensitive data such as social security numbers and credit card deals. Deterministic encryption, which consistently produces the same ciphertext for a given plain text and supports operations like equality joins, indexing, and grouping. This is ideal for fields like customer IDs or email addresses in financial or retail systems. And randomized encryption, which generates different ciphertexts for the same plain text each time, offering maximum security for highly sensitive data such as social security numbers and credit card details. Though it limits query capabilities, these encryption strategies empower organizations to tailor their data protection approach based on operational needs and threat modules, while maintaining performance and usability across diverse environments. SQL Server leverages secure enclaves to enhance data protection and enable advanced querying capabilities on encrypted data. Secure enclaves are protected regions of server memory where sensitive data can be decrypted and processed securely, ensuring that even during computation, the data remains shielded from unauthorized access, including from privileged users and debugging tools. This technology is especially powerful when used used with Always Encrypted, as it allows for operations like pattern matching and range comparisons on even randomized encryption data, which are typically not possible with traditional encryption methods. The diagram shows how plaintext data is encrypted by an enhanced client driver, stored as ciphertext within SQL Server, and then it's securely decrypted within the enclave for processing. This capability is particularly beneficial for a lot of industries, like we mentioned before, finance, healthcare, government, where sensitive data must be protected at all stages: storage, transit, and computation. Also, it still supports complex analytical reporting. By integrating secure enclaves, organizations can achieve robust private data. Here is a clear step-by-step visual guide for configuring encrypted connections in SQL Server Management Studio, or SSMS. This is a critical measure for securing data in transit. It begins on the SQL Server Configuration Manager, expanding SQL Server Network Configuration, right-clicking Protocols and choosing your server instance, and then selecting its properties. On the Certificates tab, where the administrator can select or import a valid SSL or TLS certificate to be used by SQL Server, this certificate is essential for establishing secure communication channels. Next, the Flags tab allows users to enable the force encryption setting, ensuring that all client communication to the server is encrypted by default, eliminating that risk of unprotected data transformation. SQL injection is one of the most common methods used for data breaches. The core of the attack is that a SQL command is appended to the back end of a form field in the web or application front end, usually through a website, with the intent of breaking the original SQL script and then executing the SQL script that was injected into the form field. This SQL injection most often happens when you have dynamically generated SQL within your client application. The core reason behind SQL injection attack comes down to really poor coding practices, both within the client app and within the database stored procedures. Many developers have learned better development practices, but SQL injection is still a big problem due to both the number of legacy applications still being used and newer applications where SQL injection wasn't considered while building the application. Azure Key Vault is a secure cloud-based tool for storing and accessing secrets such as passwords, certificates, and cryptographic keys, typically accessed programmatically to support secure application development and operations. It plays a critical role in protecting sensitive data by offering centralized management and integration with services like Azure Virtual Machines and SQL Server, where it can store encryption keys for features like transparent data encryption and Always Encrypted. Azure Key Vault is also compatible with on-prem environments, making it ideal for hybrid infrastructures. A key security advantage is its independent role-based access controller, RBAC, meaning even Azure subscription administrators can't access the vault unless explicitly granted permission. This separation of access ensures tighter control over sensitive assets. Benefits include enhanced security, simplified key lifecycle management, and regulatory compliance, where protecting secrets and managing encryption keys securely is essential. Now it's time for our knowledge check. Question 1. What feature provides a private IP address for an Azure SQL database? Answer: private link. Question 2. Which technique can be used to create database firewall rules in Azure SQL Database? Answer: executing a T-SQL statement. Question 3, which feature prevents members of the sysadmin role from viewing the values of data in a table? Answer, always encrypted. Now let's look closer at how to configure Azure SQL Database firewall rules. Hello, now let's start Lab 4. Implement a secure environment. This is a good lab to kind of reinforce what we know about working with firewalls here inside of Azure. So what we're going to do is we're going to go and use a lab server, a SQL server we've already created to do this. And I'm going to go into Azure SQL again. And you can pick it from the top if you don't see it, to get it, type it in, to search for it. And when I get to Azure SQL here, I have a number of servers that I've created, one of which I used a bit earlier. And it is our Lab 300, DP-300 Lab 1. And on it, we have a number of databases. This is AdventureWorks LT and LT2. So I'm going to go into the database, but to configure the firewall. And it could be done through the portal of our server, but not necessarily through the SQL database. So it's nice to be able to come in here and see the name of the server. And I can also, I don't really have some of the same options that I might have had available earlier if I were on the server. But here on the database and on the LT2, both are writing on that DP-300 Lab 1 database server. So I'm going to go back out and I'm going to come down to the Lab 1 DP-300 Lab 1 server here. And I'm going to go into networking, and I already set up some of these settings from a previous lab, but I want to verify that our firewall is good, and I have the client that I can get connected here. So this is essentially a server level firewall rule that can be done right here in Azure, adding the client in. But to be able to do the database one, we have to do it at the database tier. And one of those options is definitely working with our SQL Server Management Studio. So let me make certain I've copied the server name that we want to get connected to, so it looks good. And now I'm going to go into the Management Studio and I'm going to get connected to it. And I've done this a couple times, so it might be familiar to you right now. Now I'm going to go into and connect to the database. I'm going to paste it in here, and here it looks good. And I'm going to choose the SQL Server Authentication. I'm going to log in. I'm going to use that DP-300 admin there. And now the DP-300 admin, I'm going to use that to get connected into the server and get into the database. And so we're going to put the password here. And again, I'm going to trust that server certificate. I'm going to use that to connect, and we can get in hopefully easily right here. And we see the databases that we saw a little bit in Azure, the AdventureWorks LT and our AdventureWorks LT2. So I have two databases here, but I want to create another. So there's another option. We can choose to pull a database in here. And that option is I can import from right here. So I'm going to go into databases, and I'm going to pull that in. And when I do that, I get to the backpack window where I can go find a backpack file. And one of our files that we have from our lab files is in here. It's Lab 4, all files, Lab 4, AdventureWorks LT backpack. And I'm going to pull that one in right here. And I'm going to hit this next, and it's going to give me some options here on how to configure this. And this is going to be the new database name here that I'm going to pull in, which you can use. We can set this up by the Management Studio. You can create a backpack file also from the Management Studio. But you can see what I'm going to do here is I'm going to adjust this and make it basic. So I'm going to choose basic from this list there. And I'm going to modify the name a little bit. And I'm going to add it in from my backpack file. So this will make a new database. So this file that we can use to move from one server from another backpack is very handy. You have the backpack options, so you have import. You could also export a database to backpack if you'd like. So I'm going to click next. And when I do this, it's going to take a while to run. It's going to give me a little bit of time here where I can look at the results. And I'm going to click on finish. And so we can wait for that to happen. So this is one option here, working with doing an import of a database that has already been exported, maybe from another SQL server, and we're trying to move it from one system to another. This backpack file is handy for that. The backpack will include not only the database schema, but all of the tables and records inside of it will be helpful for us here. So let me see if I can run something while we're, okay. So I'm going to go ahead and real quick, I'm going to right click here on any database, and you can go onto the option where you can have it do some additional tasks. And so if you do an export, notice it exports it as it does. It creates a backpack file. So the export is a way to create a backpack file of your database, and then right-clicking it and choosing Task to Export is what I did, and you can make a backpack file very easily. And after it's created, of course, you can go back in to databases and you can actually import the backpack file, which is a process we're doing right now. So export and import for the backpack file here if you want to work with the database. Now let's see where the window is right now. And you can see it's still running, so we can use this. So this is the backpack file. You can do an export of the database and then an import off of databases to move a database from one location to another. The other option is a DAC pack, which is just copying the schema and not necessarily the records inside. So I want to do that very easily. Same spot, I can go into the database I want to use, going into tasks and choosing extract data tier. When you choose extract data tier, this is used to create a DAC pack. And notice I just want to go in and I can say what I would like to have created. It's going to create a DAC pack for me here. And it's essentially going to go through and validate it. And it will pack up the database into a DAC pack, which essentially, again, is just the schema, but no records in the tables. And so the backpack is import and export. And to make the DAC pack, we're talking really about using an extract and a deploy. So you extract and deploy for the DAC pack that doesn't have any records but the schema. And you import and export for your backpack, which will have the schema of the database and all the records inside. So a lot of options to choose from here. And we'll give it just a little bit to run. So a lot of options. And let's see where we're at in this process. And it looks like we're done. So I had a little bit of time to kind of get that to run. Looks like it ran. This should create a new backpack right there in our list, a new database from this backpack. And so we have it extracted. It took a little bit to process it. And now we're going to do is we're going to set up a firewall, a database firewall on it. So remember, let me go back into Azure for a moment here. And if I go back into Azure, do we have that new backpack in here, that new database we made from the backpack? Yes, momentarily it will show up here. So I'm going to have it to refresh. I'm going to have to refresh this a moment, but we added it to SQL, so it should be here. And here it is right here. So we can make it here inside of Azure, or we can make it in the Management Studio. A couple ways to add your databases. We have 3 databases riding on top of our one server here, our DP-300 Lab 1. Okay, so I'm going to come back to the Management Studio, and I'm going to do a firewall from here. So remember, I have a firewall open on the server, and I want to have one with a contained database user here to authenticate at the database tier and below. So I'm going to create a firewall for them, And then I'm going to go add an account. So this is the firewall. This is a database firewall rule. So it's a stored procedure where I'm going to set database firewall rule here, and I can not do this in the portal. And I'm going to put in my client IP address here so that we have that. So we just got a list this, we're just going to list this here. I'm going to type it in, and then I'm going to go ahead and copy this. And I'm going to make this the start and end IP address. And I'm going to put it in our IP address to come through to be able to get it through the server firewall. And now I have a database firewall, and we're going to put in the new backpack database. Now it looks like it's going to take a moment. So let me refresh this here so that we can see that SQL picks it up. Then I'm going to see, let's see, I can still pick it up. So I'm going to do this, and I'm just going to add it here to the top, a little bit of a refresh issue. So we can use this. It's the database called AdventureWorks and AdventureWorks LT. From Backpack. And just make certain I've typed this in. I'm going to execute this one line here. Whoops. So we got an error. I'm going to hit the space bar here and see if we can get that to work. So is that spelled correctly? AdventureWorks LT. What I might do from the backpack is we may have to use the word, we may have to make some changes to it. So let's see if I can find it. So somehow it might be having a hard time finding that it wants me, and it wants me to create something, a new connection. So usually I can make this work. It's usually the case, but we'll go ahead and go make a separate location, and we'll test it out again. So it looks as though it's not seeing this just yet. So it takes a little bit to refresh it here. And we'll give it a little bit more time to get connected. It's just having a hard time. Let me come out here and let me copy and paste this into another window. And let me copy that and let me close some of these right here. I'm not going to save these. So let's see what it does. And then I'm going to try it one more time. Sometimes you have to do a little bit of refreshing here for it to find it. And let's see if it finds it now. So we'll refresh it, we'll execute it, and it looks good. Yeah, it just takes it a little bit to write it on the Azure side, and I get a little impatient on this end. And we want to make a new user, and I'm going to come out here and paste this in, and this is telling it that we're going to make a contained user. And I think it's having a little bit of a hard time, but that's no problem. Let's see if we can get it to work here. So we'll make this new user on the database. So you remember that under security and users is where we want to add them. There's some default user there. Let's make this new user. And because we're talking about working with the Azure SQL Database, it doesn't necessarily have the option to work with a login. So we're going to do this at the database tier. So remember, you can't create a login for an Azure SQL database, but you can make a contained user on that database. And we'll run this command here. And so it already exists. So it's already picked it up. I'm going to refresh it now. And let's go ahead and pick this up here. I'm going to refresh it, and we'll see if that person is there. And yes. So there's the contained demo user. So no problem with this. We just note that we have, I was able to run that second portion there, and it just takes a little bit to get connected. Trying to demo the fact that you cannot make a login for an Azure database. You have to do a contained user. And we're going to go ahead and click on Connect, and we're going to try to log in with this contained user. So we have to connect to the database. We're going to put in the password. for the contained demo. And let's see now. Now I tested this out before, and let me take off the name of that database here, but you do have to tell it the database name. So we're going to hit connect. Well, it doesn't necessarily have a server tier, if you remember. So if you want to use that contained user like this, I'm going to have to actually put the name of the database in because there's no server tier. Trying to highlight that. But if I come here and pick up the name of the server, actually the name of the database that we'd like to get connected to, it'll act a little bit different here. And then it's from the backpack. And let's see if I can get connected to this one. And hopefully this will work for us. Yes, and there it is. So it just takes a little bit of refreshing to kind of make this work. And if you want to use the contained user when you get connected, you have to go to that separate tab to add in the name of the database. So trying to show you some things that you may run up against as you do this. So we have the firewall that's at the server tier that we created in Azure. And then you have the firewall at the database tier that we made here inside of the Management Studio using T-SQL. And you can get rid of that URL, and that's the option. We're going to go back into GitHub here, and you can see the URL right there if you want to get this lab instruction downloaded, or if you want to use it off of GitHub or our DP-300 lab list. So you have lab files if you need to download those also. Thank you for your time and attention in this optimization section. I look forward to seeing you in the next.